This is our second part of Unit 8, where we're talking about energy. Energy is the ability to do work. Here are some forms of energy that we'll be discussing on the next few slides, but it's important to realize that energy cannot be created nor destroyed. But what happens is it changes from one form into another, which we will take a look at here. So let's talk about our first form of energy, which is mechanical energy. Okay, that's where energy is stored and it can result in motion. So we've got the words potential energy and kinetic energy. Kinetic means movement. It could be found in windmills, flowing rivers, somebody even running or walking, and also in your car. We've got chemical energy, which is energy that's stored within bonds of atoms. And this we can look at how it's found in food and fossil fuels and even in batteries. So think of that keyword obviously is chemical. So anything where there's chemical bonds happening. We also have electrical energy. So this is when energy is from moving electrons and they usually derive from some other type of source. So like if you think about at your house, right, we have electrical energy and that's coming from our power plants, that's in our outlets, and it also can be created by lightning.
So in addition to those types of energy, we have three others that we're mentioning. Thermal energy or heat energy is energy created when molecules move, all right, when they vibrate. So whether they're atoms or molecules and they are moving. The faster those molecules or atoms move, the hotter something gets. Okay, think about boiling water, right? You put a pot on the stove and the hotter that water gets, the more bubbles and faster the molecules move because they're changing from liquid to gas. We have thermal energy, right? Our heating system, we're definitely going to be using that in this next month or so with how cold it's getting. Usually, though, you find thermal energy paired with or converting or changing with another form of energy, a light bulb, for example, which we'll talk about in a minute. Radiant energy is our next type, or light energy. This is a type of energy that comes in the form of electromagnetic waves. Basically, that is a type of kinetic energy or energy of motion. So molecules, particles, photons, really fast, tiny things moving really fast, but they move in waves, all right? Obviously, radiant or light energy comes in the form of visual light, and that's those photons coming out of, like we see from the sun. All the different types of rays. So you've got UV rays, ultraviolet rays, you've got infrared radiation, you have X-rays, you've got other types of wave forms like radio waves, and then obviously all of our stars in the night sky are providing us with this type of radiant or electromagnetic energy. And lastly, for our class, we're going to talk about nuclear energy. Nuclear energy comes from when we take a nucleus of an atom and we either split it, right, via fission that we talked about in our nuclear reactions chapter last semester, or we fuse two smaller nuclei together and huge amounts of energy gets released, like what happens inside of the sun and other stars. Okay, this fusion is what's going to happen in the stars, and then fission is going to happen in places like our nuclear power plants, where you have those chain reactions of atoms being split and lots of energy being released. And then we harness that energy and we use it to power all sorts of things.
So when we talk about transformations, we're talking about that energy transforming from one to another, right? Energy can't be destroyed, but it can be changed from one type into another. So some examples of those would be chemical energy into mechanical energy. So an example would be just like that first picture there, where somebody would be eating food, and that allows your muscles to move. So working out, walking, and so on. Okay, that is one example of chemical to mechanical energy transformation. Radiant energy into chemical energy. Again, that next example there is that radiant energy is coming from the sun, and plants are absorbing that in order for photosynthesis to create food for themselves. And then we also have electrical energy into thermal energy. The example here is a toaster. Okay, you're plugging in your toaster into the wall. That's where you're getting your electrical energy, and it's turning into thermal energy because it is heating up within that toaster and making your bread into toast. So creating almost like a burn mark on them. You should also be able to create some additional examples to help you understand the difference and how energy is transformed.
As Ms. Case just mentioned, energy transformations, we want to make sure that we have a direct transformation because energy is not created, it's not destroyed, it just changes forms. So we go from one form, like chemical, into another form, like mechanical. But sometimes we have non-efficient or wasteful transformations. So if we don't have an efficient transformation, that means that I'm going to use the word lost, even though that's not the right word. We have kind of a wasteful transformation as part of that process. So we're going to talk about two examples where we see this in action. The first is an example of electrical to radiant energy, which would be a light bulb, right? So this example would really be more for older light bulbs because now we have like LEDs and all these very energy efficient light bulbs where we don't see this as much, but bear with us because it is a good example here. So obviously we use the electricity to convert that electricity into light, right? Turning the light bulb on so we have light and we can see. But with those older light bulbs, a lot of the time is that electrical energy would also get converted, in addition to light, would also get converted into thermal or heat energy. And so what would happen is those light bulbs would get really, really hot. We don't want that heat. That's not the goal of the light bulb. So we have what we consider a non-efficient energy transformation. Hence the development of light bulbs like the LEDs, where you don't have that wasteful transformation and you don't have that lost energy from the radiant into thermal. We keep that light energy as light and we don't get that heat anymore, right? The second example is going from chemical into mechanical, and we see this example of non-efficiency in a car. So the goal transformation here is going from a chemical energy, so in gas typically, to mechanical, obviously to physically move the car, right? But you could see there, statistically speaking, over 60%, all right? That's more than half of your gasoline, of that chemical energy that's in your car, gets transformed into heat energy, not mechanical, all right? And that heat energy doesn't help to propel my vehicle. So I'm paying for only a usage of 40% of my gas when I put that into my car. That's a bummer, right? That is a non-efficient transformation. Again, hence the development of hybrid cars, electric cars, cars that aren't relying on the chemical energy in gasoline, but using other sources of energy that aren't going to result in that non-efficient or wasteful transformation, so that we're getting more bang for our buck when we put that fuel into our vehicles.
All right, so finding better renewable sources of energy. Obviously, renewable energy, just like Ms. Laporte said, is important. Energy generated from natural replenishable sources like the sun, the wind, the rain, those are all considered renewable energy. It can be generated over and over and over again, and doesn't need to be made or waited in order for it to be available to us. Non-renewable energy is energy sources available now and only with a limited supply, such as fossil fuels like coal and oil and natural gas. It cannot be regenerated in a short span of time. It takes longer amounts of time to create this type of energy, which makes that non-renewable. Okay, we can't get it quicker.
And so this is what we will transform into as we head into earth science, is looking at some of these other types of energy to be able to do a lot of the things that we do here on our planet.